Okay, today we are going to start with the sulfuric acid, the very important topic in the entrance point of view as well as in our daily life also. Okay, a country's economy itself is calculated on the basis of consumption of H2SO4. That much is the importance of the sulfuric acid and most scoring topic in the entrance examination point of view also. Okay, so that's why the name itself, the nickname of the sulfuric acid is king of chemicals. What it is called as king of chemicals. Okay, so with the nickname itself, you can understand the importance of it. King of chemicals means a country's economic deciding factor of the chemistry. Okay, how much a developing country is estimated upon how much of the sulfuric acid is produced and how much it is consumed. More consumption, more production means it is a developing country. Okay, that is the general advantage of the sulfuric acid. Because of that it is given with this name, king of chemical. Okay, now we are going to let us study about the what are the uh, sources from which it can be produced. Okay, the main source of the sulfuric acid is SO2. Okay, the only one source is there from which we can easily manufacture advantageously sulfuric acid. Okay, sulfuric acid can be easily prepared and most of the methods are using the sulfur dioxide only. Okay, so because of the uses, sulfuric acid is called as king of chemicals, and sulfuric acid in almost all methods involves use of the sulfuric acid prepared from the sulfur dioxide only. The only compound from which sulfuric acid is prepared is sulfur dioxide. Okay, but by using this broadly, they are prepared in the two parts. They are prepared in the two methods. Okay, in the small scale, that is lab method. Okay, laboratory method. Understood? And second one is industrial method. What is the next one? Industrial methods. Okay, so for easy to understand, for easy to memorize, I have divided the sulfuric acid preparation method into how many methods further? Total five methods, but broadly broadly two method. In lab, there will be three methods, and industrial two methods. Okay, so total methods of preparation sulfuric acid is five methods, and they are all prepared from the main source of the sulfuric acid preparation is solely sulfur dioxide. Okay, first one is catalytic oxidation. Catalytic oxidation. Okay, first method. Second one is chlorine or bromine water method. Bromine water method. Okay, third one is oxidation, oxidizing agent. Third method is by using oxidizing agents. Okay, then in the industrial method there are two methods: lead acid chamber method or lead chamber method. Okay, and next one is most important process is contact process. Okay, so these are the these are the total methods of preparation. These are the total methods of preparation of sulfuric acid. Okay, first one, sulfuric acid is called as king of chemicals. What it is called as? King of chemicals. Okay, so because of its advantages, because of the wide use of the sulfuric acid, it is called as king. Okay, why it is called king of chemicals? Because of its wide use. Okay, and we can call it as a king because of is going to give you a good number of marks if you concentrate on this topic. Okay, so if you study easily, if you study with concentration, the sulfuric acid itself is going to make you king by giving you a good score. Okay, so sulfuric acid is mainly prepared from where? It is prepared from the only one substance, that is sulfur dioxide. Okay, and it is prepared by how many method? Broadly two methods: lab method and industrial method. In lab method, we are going to prepare it from the three methods by using catalytic method. Second one is chlorine or bromine water method, and third one is oxidizing method. And fourth one is, which is a part of the industrial method, it is called as lead acid chamber method. It is an obsolete method. It is an old method. Nowadays it is not used, but it is there in our entrance syllabus, in our NCERT syllabus, in our board syllabus. That's why we have to study. But currently using method, presently and currently using method is contact process. So that's why you should be concentrating on the contact process very definitely. Okay, it is going to give you at least one objective. Understood? So, but in what way objective will be there and how you have to select the option, that I am going to cover it in the topic. Is it understood, students? So this is what we are going to study. Today we are going to concentrate mainly on preparation structure. Okay, if it is completed within the time frame, then we are going to complete the properties also. Okay, so to improve or to reduce the time, then what I am going to plan is to give you a worksheet or to give you a note. Okay, written note as a PDF form. If it is possible, I will give you a link, a link of the handwritten notes and handwritten assignment. We can find it along with the video. Is it understood? So that it will reduce the time to write the notes. But let us see if it is possible or not. Then I will give you in the explanation. Understood? So these are the topics we are going to study in this. Okay, so these are the three lab methods. Okay, first we are going to concentrate on the lab method. The first lab method is catalytic oxidation. Okay, in catalytic oxidation, sulfur dioxide oxidized with the oxygen, atmospheric oxygen in presence of water, and catalytic name itself suggests we should use some catalyst. And what is that catalyst we are going to use? That is V2O5. Okay, so V2O5 is used as a catalyst for conversion of sulfur dioxide, into sulfuric acid. For conversion of sulfur dioxide into sulfuric acid, what we have to do? We have to use uh, B2O5 as a catalyst, and it uses oxygen from the atmosphere in presence of water. It converts into sulfuric acid. This is the first lab method. So lab method differs. How it differs from the other? That is because of the quantity we can use, because of the V2O5, and it is very difficult to handle large amount of the gases. This method cannot be used for the industrial purpose. Okay, so it is used only when high purity is required. When high purity is required, but small quantities are also required, this method is used. First method is catalytic method, which uses sulfur dioxide plus oxygen plus H2O gives H2SO4. Catalyst is V2O5. Okay, and what is the use of the V2O5? How it is going to function as a catalyst? We are going to discuss in the advanced classes. Okay, there are catalytic procedures are there, but there are, one is called as homogeneous catalysis, another is called as heterogeneous catalysis. Okay, so for the time being, you should remember V2O5 is a catalyst used for this purpose. Okay, second one, see, this I am going to cover, or I am going to give you in the notes form. Okay, in the PDF form I am going to provide you. Understood? But only for those students who are present at this video. Okay, now SO2 plus chlorine water. Okay, so SO2 plus Cl2 plus H2O. Okay, so it is going to give H2SO4. What it is going to give? H2SO4. Is it understood? Now, what else it is going to form that, and how it is going to form? I am giving you just a mechanism. Okay. So how to remember? How to remember these procedures? Okay. So first, what it will form? H2O plus Cl2. What it will form? HCl plus HOCl. Okay, first step is H2O plus Cl2 gives HCl plus HOCl. Okay, out of this, which one is more reactive and which one is about to react further? Okay, very good. HOCl is further reactive because it is unstable and it is oxidizing agent. Okay, so SO2 plus HOCl. Okay, what it is going to form, this is oxidizing agent. This oxygen is going to transfer here and it will form SO3 plus HCl. Okay, and this SO3 plus what we left in the reactant side, this H2O is left in the reactant side. Then it is going to form H2SO4. Okay, so this is the final product. This is the mechanism. That means reaction of the chlorine water on the sulfur dioxide proceeds in how many steps? Three steps. First step is formation of hydrogen chloride and hypochlorous acid. What is HOCl? HOCl is hypochlorous acid. Okay, and this hypochlorous acid when reacts further to give its oxygen, nascent oxygen, it is provides to the sulfur dioxide. Okay, and it will form SO3 plus HCl. SO3 plus H2O gives H2SO4. Is it understood? So H2SO4 is the final product. This is the net reaction and this is the mechanism. Okay, next. Sulfur dioxide plus oxidizing agents. Sulfur dioxide plus oxidizing agent. Okay, so the main problem lies in oxidation of sulfur dioxide to sulfur trioxide. Okay, so let us say first example H2O2. Just as a layman also you can write it simply. What it is going to form? H2SO4. Okay, so this will takes place in how many steps? Two steps. Okay, H2O2 first decomposes to give H2O plus nascent oxygen. Okay, that nascent oxygen provided by H2O2 react with the sulfur dioxide in presence of H2O to form H2SO4. Is it understood? This is the mechanism of the second reaction. Okay, and third one is very easy. SO2 in this ozone. Okay, plus O3 plus H2O. Okay, so what it is going to form? H2SO4 plus O2. Okay, ozone is an oxidizing agent. Is it understood? So now we have completed about how many steps? Three methods of preparation, lab preparation method. What are those lab preparation method? First one is catalytic oxidation. What is the first method? Catalytic oxidation. Okay, catalytic oxidation, what we are going to use? Oxygen, and as a catalyst we are going to use V2O5. Okay, what is the second one? Second one is by chlorine water. Okay, chlorine water, that is Cl2 or Cl2 plus H2O. Okay, so it takes place in how many steps? Three steps it is going to take place. Otherwise, in place of the chlorine water, what else we can use? We can use bromine water also. Okay, we can use bromine water also, Br2 plus H2O. Okay, that is the second preparation method. Okay, and third preparation method is by using oxidizing agents. Okay, by using oxidizing agents. Further, there are how many parts? Two parts are there. First one is First one is H2O2 we can use as oxidizing agent. Third one, next one is ozone. Okay, so their ultimate aim is to provide the oxygen. Main step is the SO2 plus O2 or some oxygen it requires to form SO3. Okay, so this step oxygen is provided by either H2O2 or ozone. Okay, so in the H2O2 additional water is not required because already H2O is present with it. Is it understood, students? So this is about the preparation of the sulfuric acid in the laboratory method. Okay, next coming to which methods? Very good. Okay, next method is industrial method. Okay, so in industrial method, how many methods I told you? There are two methods. Okay, so in industrial method there are two methods. First one is lead chamber process. What it is called as? Lead chamber process. Okay, before going to study this only, I will tell you the disadvantages. Okay, I will tell you what disadvantages. Okay, so why it is not much used. Okay, now listen. So let us industrial methods. Industrial methods, the main method is lead chamber process. Okay, First one, it is the costliest method. First disadvantage is it is the costliest method. Okay. Second one, it is a method which uses gases, corrosive gases in the reaction. Okay. And third method is it yield is very less. Only 80% of the sulfuric acid only prepared. Remaining will be impurities. Okay. The main reason we can say because of the low yield and difficulties, practical difficulties experienced during preparation. Okay, industrial method, lead chamber method is nowadays obsolete. It is being replaced by the good yield method, that is contact process. Good yield method, that is contact process. Okay, in the contact process, what it is going to give you? High percentage of yield, around 98% of pure sulfuric acid is used, and it is also less expensive. Okay, in industrial process, what we are going to concentrate on expenses and percentage yield. We want that maximum product should be produced by using minimum equipment and minimum expenditure. Raw material should be low cost. Okay, so first lead acid chamber is named because there are going to be lead lining. What they are going to be? Lead lining. Okay, so because of the lead lining, this is called as a lead acid chamber or lead chamber method. Okay. In this process, we are going to call it as a NOx. Okay. NOx is a NOx is a nitric oxides, nitrogen oxide. NOx is just a full form is nitrogen oxide. There are 5 nitrogen oxides, but we are going to prefer a nitrogen dioxide. Out of 5 oxides of nitrogen, which we are going to use nitrogen dioxide because of its highly unstability and good oxidizing agent. Okay, good oxidizing agent. Is it understood? Okay. So first step involves NOx. NOx is nitrogen oxide. Which oxide we are going to use? N2NO2. Okay. So sulfur dioxide on oxidation with nitrogen dioxide. Okay. Nitrogen dioxide is unstable. So this oxygen is transferred over here. Then SO3 plus NO. Okay. Now the main disadvantage of this process is this step. Okay, this is the step 1. In step 1, what we are going to do? Oxidation of sulfur dioxide with NOx. Okay, then S plus this, sorry, SO3. Here we have to react with steam. See, sulfur trioxide itself is a highly corrosive gas. Okay, it is a very difficult to deal with the sulfur trioxide, and again we wanted it to react with the sulfur water that is also at a high temperature. Because of this only, this method is very disadvantageous. That is the practical difficulties faced in the lead acid chamber or lead chamber method. Is it understood? Because of this. Okay, and sometimes what happens, this nitric oxide or nitrogen dioxide. Okay, nitrogen dioxide, if they are not reacted completely, what they will do, this or this will come and react with the water. Okay, so suppose these two are reacted, then what it is going to give? HNO2 they are going to give. These two are reacting, what they are going to give? HNO3 we are. Okay, so even though they are good product, but our aim is to prepare what? Our aim is to prepare sulfuric acid. But instead of preparing, we are preparing some impurities also along with this. Okay. So why lead acid chamber is not used nowadays? First, difficulty in handling of sulfur trioxide with steam at high temperature. Second one, impurities. Maximum yield of the lead acid chamber process is what? Only 80%. Okay. So because of this, now we are going to get on to the most important topic, that is contact process. Okay. Contact process, why it is very advantageous, how it could overcome the disadvantages of lead acid chamber or lead chamber process. Okay. First method, it does not use a costly material. It uses a sulfide ore when undergoes roasting. Okay. Main problem is when sulfide ore like FeS, otherwise zinc blend. Okay. Iron pyrites or copper pyrites. Okay. When they are extracted, actually during the extraction in your 12th class or in second year or 12th class, there is a topic extraction of metal. There you are going to study. This is called as a roasting method. What it is called as roasting method. Okay. So in this one, it is converted into oxide and sulfur dioxide. Okay. So when it is oxidized, it is converted into oxide and sulfur dioxide. That means these are the byproduct. Okay, we are not going to prepare sulfur dioxide in this method any separately. Okay, we are going to use the waste gases. Okay, sulfur dioxide are the waste gases obtained during the preparation of the metals. Okay, so because of this, we are doing two great things. First one, we are reducing the pollution. Sulfur dioxide, if it released into atmosphere, it is going to create a pollution and it is going to cause acid rain. Okay, first we are saving our environment. Second thing, what we are doing, we are reducing our cost. Okay, so if some uh, industry is there which is preparing, which is extracting iron or zinc metals, if you ask them to provide the sulfur dioxide, they will be easily provide the sulfur dioxide because it is very going to be harmful to them also. Okay, so that sulfur dioxide, okay, which is procured from the industry waste, is going to use. That is the advantage of contact process. First advantage is it understood, raw material used are cheap method. Okay, second one, that is the first step. Okay, so if you want costly, then S8 also can be used. Second, FeS during oxidation or ZNS. This is the step one. Okay, all of them, what they are going to give you, sulfur dioxide. Okay, the main step lies over here, very very important for the competition point of view, SO2 plus O2. Okay, earlier we used to have platinum. Okay, nowadays we replaced it to V2O5. This is a very very important question. Okay, so sulfur trioxide, understood, balancing, and I am going to write a special interest with delta H minus 196. It is approximate value, otherwise 197 also we can say. Value is not much important, this sign is much important. Okay, so here this is the heart of the, this is the best process of the this entire contact process, because it is a reversible process. What it is, reversible process. Okay, so in the reversible process, to keep the reaction on the right hand side, what we will try to do, we will try to do it on the Lee-Chatter principle, work as per the Lee-Chatter principle. Okay, so first one is we will pump in the more sulfur dioxide and oxygen continuously. We will take out the sulfur trioxide as soon as possible. Okay, they are the conventional and common methods. Okay, but the main method we are going to use is pressure method. Okay, here how many moles of gases are there, 3 moles, and here how many moles of gas are there, 2 moles. So we wanted to move in the direction where number of moles are increasing. So for that, sorry, decreasing. For that, high pressure is required. What is the requirement? High pressure is required, and it is the exothermic process. So temperature should be low. Okay, but when you keep the temperature low, the main problem occurs is, what is the main problem? It occurs, main problem because of the, main problem lies in, the main problem because of the what, rate of reaction. When temperature is low, rate of reaction will be very slow. So to avoid that, what we have to do, we have to maintain optimum temperature. Okay, normally industrially we maintain a 7 bar, sorry, 2 bar pressure and 700, nearly 700 Kelvin. Okay, so if we can maintain below this temperature, it will be very nice. But main problem is that if you decrease the temperature below this, it is going to reduce the yield rate of the reaction. We will get good amount of the sulfur trioxide, but it is going to take time. Is it understood? So that is the advantage and disadvantage of contact, this second method. Okay, now I told you platinum. Okay, so mainly sulfur belongs to 16th group. It comes with the arsenic. Sulfur dioxide sometimes contains arsenic impurities. Okay, arsenic impurities. This arsenic impurity act as a catalytic poison. Okay, catalytic poison for platinum. So that's why platinum cannot be continuously used. After certain time we have to wash out the platinum because it is being poisoned by the arsenic impurities. That's why arsenic purifier also sometimes used. Nowadays platinum use also obsolete. Now it is replaced with the V2O5. V2O5 cannot be poisoned by the arsenic. Okay, so now we are going to get the second step. What we got? Sulfur trioxide. Okay. Next is spray. Third step is spray. Sulfur trioxide plus H2SO4. Okay. So here you should get doubt. Here you should get doubt that why sulfuric acid again used. Okay. So that you will come to know now. When it is H2SO4, it is going to give H2S2O7. Okay, H2S2O7 on dilution. What it is going to give? 2 moles of H2SO4. Okay, so that's our investment is 1 mole, and we are going to get 2 moles of sulfuric acid. We are going to get how much? 2 moles of sulfuric acid. And because of this reaction, we are avoiding that hot gases. Because of this reaction, we are avoiding hot gases. Explosive nature is avoided because of this reaction. Is it understood? So that is the advantage of contact process. Okay, and sulfuric acid structure, I think everybody know. This is the sulfuric acid structure. Okay, is it understood? How many sigma bond? 4 sigma bond and 2 pi bonds. Okay, bye.